In the last video of this course, we looked at the built-in panic and recover keywords. Now, in that video, we had a small glimpse of the defer keyword and how we could use that to defer the execution of a function. In this video, we're going to take the concepts that we looked at one step further and really dive deeper into what deferred functions are and what they can provide for us as Go developers. Now, deferred functions are something that are used a lot within Go when it comes to doing things like setting up, say, connections to databases or brokers. Typically, we end up using a deferred function to ensure that connections are closed after we're done with them, so we don't have stale connections hanging around. Okay, so let's dive into the code and see how we can define our own deferred functions in a small example. Now, we're going to start off by defining one deferred function here. So we're going to use the defer keyword. We're going to use an anonymous function. And then within this anonymous function, we're just going to do fmt println I will be executed last. And then we need to remember to put parentheses at the end of this anonymous function like so. Cool, let's open up the terminal and let's do go run main.go to run this application. And as you can see, the body of our main function is completely executed. So we see this fmt.println statement deferring go printed out first. And then it's only after the body of the main function has completed that we see the defer functions then executed. Now, when it comes to having multiple deferred functions in a function, we'll see that these are executed in a last in, first out order. So last in, but first out. So when we run this, we expect to see that this deferred function will be executed first, and then this one will be executed last. So let's validate this now by going into the terminal, go run main.go. And as you can see, the body of our main function is executed, and then the last in but first out function here is then executed, and then finally the first deferred function that we added is executed last. Cool. So why is this necessary? Well, I like to think of deferred functions as helpful to-dos that I can add to my code and say, okay, when we're finished executing this function, we also need to remember to do this action before we terminate. Cool. So now let's have a look at how we can do things like modifying the return values. I'm going to clean this up. And I'm going to create a new function called myAwesomeFunction. And this is going to return a named value called error or error. So the name of the value is going to be error, and it's going to be of type error. And then what I can effectively say is defer func. And I can say error equals errors.new I am an error. Cool, I'm going to save that. It's going to automatically import the errors package at the top, which we're using to generate the new error here. And then we can try and call this. So we can say error is equal to myAwesomeFunction. And then we can say if error does not equal null, then we can fmt println the error.error, like so. Cool. So my expectations are that it's going to attempt to return null. The defer function is going to come in. It's then going to update this named value return. And it's going to set this equal to a new error, which has I am an error, which is very original. Cool. Let's clear this and do go run main.go. And as you can see, when we've executed the main function, it's printed off this print line. It's then attempted to call myAwesomeFunction. And the deferred function has then set the error value equal to the new error, which we've then caught with this if error doesn't equal null block. And then we printed out this error like so. Now we saw an example of this approach to updating the named value in the last video when we recovered from a panic that was thrown in a function that we called within myAwesomeFunction. Cool. So let's see this again in another example. Let's try and do another function. We're going to call it return values. It's going to return x, which will be of type int. I'm going to set x equal to 5. I'm going to remove the nil at the end of this return statement, and within the deferred function, I'm going to do x is equal to 10, like so. And I'm going to remove this error checking, and I'm just going to do fmt.println and my awesome function, which we'll need to change to return values, like so. Cool. Let's clear this, go run main.go. And as you can see, the deferred function has effectively updated the value of x to equal 10 and then returned this, which we've then printed out in the main function. Cool. So in all of these examples, we've used what's called an anonymous function after the defer keyword. Now, an anonymous function is a function that does not have a name and is going to be scoped only to this return values function itself. Cool, so let's see an example where we pass in a named method in this case. And let's create an engineer struct with name string. Let's create a method which will take in a pointer receiver. That'll update the name with a name passed in, so string e.name is equal to name. And let's do the following. So let's create another function. We'll just call it do stuff because I am unoriginal at this point and the coffee hasn't kicked in. Let's call it, it'll take in the engineer. Let's defer the updating of this e.update name. We'll pass in my full name, which is Elliot Forbes. And let's print out doing other exciting stuff. Cool. Now within the main function, let's set up a new engineer. So ampersand engineer. Let's set the name as Elliot. And let's do the following. So let's print f. So we're using a format string here. We're going to do percentage plus v slash n. Pass in Elliot. We'll then do stuff. Pass in Elliot again. And let's clone this line here, like so. So just to highlight, this percentage plus v is going to print out the struct we've got here, the engineer struct. It's going to print out the field names and the values. So we should see name and Elliot. We're then going to pass this engineer or this pointer to the engineer to do stuff, which is going to defer the updating of the name to Elliot Forbes. And this will execute this named method here. And then afterwards, we're going to see it printed out just below here. Cool, so let's see this now. So let's go into the terminal, go run main.go. And as you can see, it prints out the struct engineer here with Elliot. We then do stuff, and then we use the named method here to update this. And then we print out again the full updated engineer object here. Now it's this sort of pattern where we're using named methods that we'll see a lot if we're doing things like HTTP requests. And I'm just going to copy and paste a block of code in here. Now in this example, we're using the http.get method in order to send a HTTP request. And then we're using the .close method on the response.body in order to close the body once we're finished with it at the end of the function. Now this block of code here actually demonstrates quite well one of the main advantages of using the defer keyword, in that when we're setting up this HTTP request, we're grouping all of the code together to handle the HTTP request and then the closing of the body. So we can go on after this to then process the rest of the body. And we don't have to remember to call this at the end of the function. So it nicely groups all of this stuff together. Cool. However, whilst it's quite nice, there is one gotcha that you have to bear in mind. And let's see that now. So let's set a new name. So var name, we'll do the shorthand notation, Elliot Forbes. Let's pass in the name here. And let's update the name to equal Elliot Forbes for my middle initial. Now what you'd expect, or what you might expect here, is that when we've updated this name to Elliot M. Forbes, when the deferred function is called, we're going to see the new name getting passed into this method here. And when we print it out again, we'll see the name is equal to Elliot M. Forbes. However, that isn't the case. Now, when Go sees this deferred function call here, it's going to immediately evaluate the arguments passed into this method. So it's going to see that the name is equal to Elliot Forbes, and it doesn't matter if we then update the name afterwards, it's still going to have the same evaluated name variable that it had when we called this. So let's see this in action. So let's do go run main.go. And as you can see, it hasn't updated it to Elliot M. Forbes with my middle initial. It's in fact kept the originally evaluated value of this name when it's called this deferred function. Awesome. So that's all we're going to cover in this video. Now, just to quickly recap, we've looked at the defer keyword and how we can use it to execute things like anonymous functions or named functions and named methods like we have here to the end of the execution of a function. We've also looked at some of the best practices around grouping things, like say sending HTTP requests and remembering to defer the response body close. And we've also looked at some of the gotchas, so the immediately evaluated argument names and how this can impact you if you're expecting alternative behavior. Cool. So this video is part of a course that's on my website, and I'll leave a link to that in the description of this video below. If you're watching on YouTube, then please leave a like and subscribe to my channel for more programming content. And if you're watching the video on the course, then I hope you're enjoying the course, and I'll see you in the next video.